All right, so transformations, guys. So we're not always, um, our lines can move around. It's not always going to go straight through the origin and be y equals x. That is what you call the parent function, y equals x. Okay, so I'm going to put that at the top real quick. Okay, so the parent function, y equals x, will go through the origin, has a slope of 1. Okay, but that's not always the case. So we're going to see how lines will be different, how will they move whenever y equals x changes. So on this one, notice we are adding something to the end. Okay, so when you add something to the end, it's going to shift it up. And the opposite, if you're going to subtract something from the very end, it's going to shift it down. Up and down. So that's a vertical shift up, vertical shift down. Okay, so if it's happening to the x, it's actually kind of weird, okay? And the way that someone told me that has helped me remember it is think about your ex-girlfriend, your ex-boyfriend. Exes are liars, right? So if there's a minus sign, I know the x-axis goes left and right. Naturally, if I see a minus sign, I'm thinking I'm going backwards to the left. But since x's are a liar, I know that it's actually going to go forward. It's going to the right. Okay, on this one we see a minus and negative, which really means a plus. So I know the x-axis goes left and right, so naturally a plus I would think would be going forward, but since an x is a liar, it's going to do the opposite. It's going to go backwards to your left. This is what you call a horizontal shift. A horizontal shift to the right is when you subtract from x. A horizontal shift to the left is when you add to x. Okay, so we're just going to graph what these look like. I know that I'm subtracting from the very end, so that's going to be down 2. So I'm going to take a few points and just move them down 2. So down 1, down 2, down 1, down 2, down 1, down 2. All right, so then I'm going to line them up and draw my line through them. Oops. Okay, on this one it's happening to the x. Well, we know the x-axis goes left and right. Don't forget, your x is a liar. Okay, so naturally a minus, I would think going to the left, but really it's going to move it to the right too. So I'm going to take a few points, move them over to the right too. So I'm going to start at the origin, move it to the right too. And I'm just going to do a total of 3. So I picked 3 points, moved them over to the right too, and I'm going to use my straight edge to draw my line. One thing you'll notice is that these look alike. So without the equation, it's hard to tell whether it was a vertical shift down or whether it was a horizontal shift to the right. Okay, this is happening at the very end, so I know that's going to move it up 2. So I'm going to pick 3 random points and move them up 2. Once I have my 3 points, I moved them up 2. I'm going to line them up. Okay, so this is adding to my x. Well, we know the x goes left and right. Naturally, we would think plus would be the right. Well, it's a liar, so I know it's going to the left. So I'm going to take my 3 points, move them left 2. So any 3 points, I don't care which ones you choose. Line them up. And the same thing with these two. So without seeing the equation and what happened, it's hard to tell whether it's a vertical shift up or a horizontal shift to the left because they look the same. Okay, reflections, steeper, which means like a mountain, super steep, right? That's what you call a vertical stretch, and less steep is a vertical compression. Think of silly putty. And if I had silly putty in my hands and I stretched it up, that would make a steeper line, right? Whereas if I compressed it and I pushed it down, it would make it compact. Kind of hard to tell on the camera. I'll try to explain that more in class. But just think vertical stretch, it's going to get longer. If you're compressing it vertically, it's going to get compacted. It's going to be flatter. Okay, so if you have a negative out front, what that means is it's going to reflect it across the x-axis. So instead of going up, it's going to be going down. That should make sense. Negative slope, right? Okay, let's talk about this number out front. If it is greater than 1, the steeper it's going to be. Which means it's going to have a vertical stretch. Think of that silly putty being pulled up and down. Okay, if the number out front is between 0 and 1, that means it's going to be a decimal of some type. So for example, 0.1 or 1/2 or so some number, a decimal or a fraction that's between 0 and 1, it's going to be less steep. Which means it's going to be flatter. Think of it being compacted, right? Compression. Okay, and you'll see examples of that here in a second. Okay, so on A we have this negative out front, which means it's reflected across the x-axis. So I'm going to pick 3 points and I'm going to reflect it. So I'm going to pick this point right here. Okay, well I know this point is 3 squares, 1, 2, 3, away from the x-axis. So whenever I reflect it, I know it's going to be 3 squares on the other side. See that? So this is 3 squares away from the x-axis. So when it gets reflected, I know it's going to reflect the same distance on the other side. Okay, so I pick this point. Let's pick this one. This one is 1 square away, so when it reflects, it's going to be 1 square away on the other side as well. All right, I'm going to pick this point too. This point is 2 squares away, so when it's reflected, it's going to be 2 squares away on the other side. All right, 3 is good for me. I'm going to line it up. And notice, it was going up, but since it was reflected, it's now going down. That should make sense. Negative slope. All right, so the number out front is a 4. So if you look back at the top, when it's bigger than 1, we know it's going to be steeper. So we're thinking of that silly putty being pulled up and down. So it should look like a steeper line, right? Okay, so let's pick 3 points and the original points. I'm just going to pick 3. I'm going to pick -1, 0, and 1. Okay, when x is -1, my y was also -1. When x is 0, my y was also 0. And when x is 1, my y was also 1. Okay. So we know that this whole thing, f of x means y, so really what we're doing is we're taking 4, we're multiplying it by the y value. So we're going to find our new points. So we had -1, 0, 1. Okay, my original y was -1, but I'm going to multiply it by 4. So 4 times -1 is -4. Okay, we're going to take 4 and multiply it by our original y, so 4 times 0, which is 0. And then 4 times my original y, which is 4 times 1. So we're using these x's and these y's. Okay, so -1, -4. So back 1, down 4. Next point is at 0, 0. That's the origin. Final point is out 1, 4, so forward 1, up 4. Okay, so I have my 3 points. I'm going to line them up. And now that you can see when the number out front is bigger than 1, it does indeed become steeper. It's like someone took that line and just pulled it vertically. It's a vertical stretch. Okay. So on this next one, the number out front is 1/4. 1/4 is between 0 and 1, which tells me it's going to become less steep. And remember, less steep is a vertical compression, so it's going to look like it's going to get pushed down. So it's going to become flatter, less steep. That's called a vertical compression. All right, so I'm going to pick 3 points off my line, original ones. And this time I'm going to be multiplying the y value by 1/4. Okay, so let's pick, let's do -4. -4, -4, so this point right here. My next point is going to be 0, 0. And then my final point I'm going to use is 4, 4. So let's find our new ones. So I'm going to use my same x's. But we're going to take our original y's and we're going to multiply them by 1/4. So 1/4 times -4 is a -1. Now I'm going to take 1/4 times my original y, so 1/4 times 0, which is 0. And then finally 1/4 times my original y, which is 4. So I'm going to use these x's and those y's. So -4, -1. So back 4, down 1. Next point is at 0, 0. That's the origin. And then final point is at 4, 1. So forward 4, up 1. I have my 3 points. Let's line them up. And you can see our new line is less steep. It's flatter, right? And it looks like someone just came in vertically and just smushed it down, flattened it out. That's called a vertical compression. Okay, so real quick, we are going to talk about, or no, not on this one. On this one, we're going to have to write the equation of what's going to happen if the slope is 1/4, if it shifts to the left 5 and goes down 2. Okay, so we know y equals, the slope is going to come out front. If I know it's moving to the left, I know that's happening to the x because the x-axis goes left and right. I'm going to put my parentheses and put an x. Okay, remember we said that x's are liars. So naturally, if I was thinking left, I would think minus. But since x is a liar, I'm going to put a plus. Down 2, oh, I'm sorry, guys. Down 2 happens on the very end. This one is not a liar. We put what we think it is. Down is subtract 2. Remember, only the x's are liars, so if it's moving left or right, it's opposite. Okay, on this one, I'm going to have y equals, the slope comes out front. I want it shifted to the right, 6. Well, we know the x-axis goes left and right, so that should be happening to the x. Naturally, right, I would think plus, so since x is a liar, I'm going to put the opposite, so I'm going to put minus 6. Only the x's are liars. So if I want to move up 4 at the very end, I'm going to put a plus 4. Okay, so on this one, we're going to talk about what how each of these would change from the parent function. So I know this 2 is going to change it. This minus 3 to the x will change it. And this plus 6 at the very end will change it. Okay, well, this number out front is our slope, 2. 2 is greater than 1. Remember, if it's bigger than 1, it's going to become steeper. It's like someone is stretching it. So I'm going to put more steep. Steeper. Okay, this is happening to the x. We know the x goes left and right. Minus, naturally, I would think backwards, which would be to the left. But since x's are a liar, I know it's the opposite. It's going to move to the right 3. Remember, only x's are a liar, so this is what we think. Plus 6. If it's a plus 6, it's going to move it up 6. Okay, number out front, that's our slope. Notice, it's a number that's between 0 and 1, a half, right? So when it's a half, it's going to be like a vertical compression, like someone's coming in and squishing it together. So that means it's going to be less steep. Okay, notice the difference between here and here. Here, this is in the parentheses with the x, so I know it's happening to the x only. I don't have anything in parentheses with the x, so that tells me there is no horizontal shift to the left or to the right. So this minus 3 is happening at the very end, which is telling me that it's going to move down 3. All right, I want you to try example 5 on your own.